Cameras make it easy to capture the way things look. But in the physical world, we learn a lot about objects by manipulating them, by poking and prodding and seeing what happens. And unfortunately, traditional images and video don't really let us do that. So in this work, we use traditional cameras and new algorithms to capture objects in a new way. And we do this by looking at tiny, almost invisible vibrations in video. So let's use this wire person here as an example. What you see here is actually a freeze frame from a 5-second video we captured with just a regular camera. And for reference, here's a video of us capturing that video. Now, remember, I said we're going to look at vibrations. So to cause those vibrations, we're just going to bang on the surface where a figure is resting while we record the video. So that's it, just 5 seconds of regular video. But by analyzing the vibrations in that video, we can learn about physical properties of our object. And we can use that information to create a new kind of dynamic video that lets us virtually interact with what we see. Our interactive dynamic video gives us a simulation of the object, which we can push and pull and interact with using a regular mouse. And this simulation was recovered from just seconds of normal video. The key to our technique is in analyzing the original video to find what are called vibration modes. Each one of these modes represents a different way that an object can move. And by identifying the shapes and frequencies of these modes, we can start to predict how the object will act in new situations. And part of what's really exciting about this technique is that it can work even when we don't know the 3D shape of an object. Take this bush, for example. Capturing a 3D scan of something this complex is usually very difficult and expensive. But with an ordinary camera and a gentle breeze, we can turn just a minute of regular video into this simulation. In this example, we kicked the support holding this jungle gym while recording less than a minute of regular video. And here's what we were able to recover. And this simulation isn't perfect, but it's a very useful starting point. And if we do have other types of information available, then we can use it to make this model more accurate. Now, a lot of the potential for this work is in engineering applications. For example, let's say that you want to look at an old building or bridge to predict how safe it is. This is called structural health monitoring, and it's a very promising application of this technology. But for now, we'll look at a more artistic use of our technique, specifically to create low-cost special effects for movies. You see, nowadays in movies, it's pretty common to put computer-generated characters into real environments, and we've gotten pretty good at this for the most part. But we're not so good at getting real things and virtual things to interact with each other. Now, if you're a big studio with a lot of money, the solution to this is simple. You film in a relatively empty space, and then you add a bunch of virtual objects for your virtual character to interact with. But we aren't a big studio, and I'm not a CG artist, so instead of a 3D character, we're going to use whatever I could whip up in MS Paint. But with our new technique, even our low-budget monster here can have fairly real-looking interactions with our real scene. In some cases, we can even use this technique on video that other people captured. For instance, here's a video that we downloaded off of YouTube that shows a model bridge in a wind tunnel. By analyzing this video, we were able to find several vibration modes, which, again, are useful in a number of different engineering applications, or, in this case, for adding an alien robot to someone else's YouTube video. In this last example, we're going to replace our virtual character with a real person. So here I am, putting on a regular biking glove, but with the power of dynamic video, we can turn that biking glove into a magic biking glove that lets me control virtual forces with my mind. For more examples and our related publications, check out the project website.